In this session, I'm going to talk about the basic time series data using R. First of all, what do we really mean by a time series analysis? Right? So when we talk about a time series analysis, we are talking about analysis of a specific data that we have collected over time. When I say over time, we have collected weekly data, we have collected daily data, or we have collected some monthly data. So this kind of a data that we have collected over time, we are doing some kind of analysis on the top of it, which also means the adjacent values. So the data of yesterday versus today, or last week's data and this week's data, there is a good chance that there is some level of dependency between these two data values. So that is what is the speciality of the time series analysis. The data that we are collecting in a sequential fashion has some level of dependency with each other, with the previous data. Current data has some level of dependency with the previous data. And that understanding of the dependency is what is handled through any time series analysis. So there are some different kinds of techniques for handling this kind of a data for different business problems. So in this specific session, I am going to look at storing, very basic aspects, storing and processing time series data in R. So here I am assuming some basic understanding of R, some basic data types. So a very basic understanding of R is already present with you. So we are only talking about storing and processing of the data in R. So what are the different kinds of classes in which I can really store the time series data? I can store them as vectors. Time series data, I can store them in a vector form, or I can store them as matrices, assuming you know the data types that are present in R. I can store them as a matrix, or I can very well store them as a data frame. And there is a specific time series object as a part of the base R package called TS. So you can store the data in any of these data types. But the scope with these different data types offered to us are very, very narrow. And the kind of methods that you can really perform with respect to time series on these data types is very, very limited. So exclusively for time series, we have some specific methods or some specific packages that are available, which I think if we can install them, that is what will create a lot of comfort for us in handling time series calculations in R. So for that I suggest a package called ZOO, ZOO. So we can install this package, or there is XTS, which is again another time series related package, or we also have something called time series. So different kinds of packages are there which can handle a lot of time series specific data, right? And even the objects are of these types. So in the package called zoo, we find objects of the type zoo. So we'll work with zoo, one of the most popular kind of a package. So we'll take some examples. We'll try to work with zoo package to try to understand the basic holding of the time series data, right? So if I have to really perform some specific sophisticated time series analysis, see, just to find out a mean, median, variance, standard deviations, I can store my data in any of these forms. But if I have to do a sophisticated time series analysis, for example, I want to do some kind of seasonal decomposition of the data. I want to break the data into seasonal components. Then, keeping my data as a vector or a matrix or a data frame will not give me any kind of a solution for this problem. But if I store my data as a type zoo, I can very well perform seasonal decomposition on the data quite comfortably. So this is where I will definitely have the need for a time series object. So let's try to use this zoo object in R and try to work out the basic time series data storage and retrievals, right? So one of the most widely used packages. So let's go ahead and install that particular package. Let me open R on my system. Okay. Once R is open, you can install. I think these packages might have already been there on my system, but otherwise I can say, okay, you install the package. You really need to select the location. So I'm selecting India. Right, I'm not installing these packages, might be there as a part of my system, but yes, let me try. If it is already there, anyhow it will give me that it is not installing. So there is a package called zoo. All right. Okay. Okay, the package zoo is successfully installed. So now we are loading this package using library command, library zoo. Yes. Okay, the package is on. Now what I'll do is, we'll take one data file example. Let me see. I have a data file, right? Let me take Sensex data file. Look at this data file simply. Yeah, here it is. It's a daily Sensex data. Right from Jan 3rd, 2000 till 31st December 2015. Almost 16 years of data is there. Right? So daily data. So we have a date column. We have, probably let me call this as Sensex. We have a column called okay, let me save it. So these are the only two columns that are present in this particular data. Now what I want to do, I want to get this data into R. It is there in CSV format. I want to get this into R. So if you clearly look at this, daily values of the Sensex. So each line on this sheet consists of a date and the closing value, and in the first line we have the heading, and the date is DD mm/yyyy. So this is the kind of format in which the data is there. Now let's read this data into R. So this is the data. I'm calling it as sensex. I'm creating a variable, R variable called sensex. So I'll have to read that data. I'll read it as a zoo data type. I'll not read it as a simple vectors or a data frame. I'll read it as a zoo. So that's where I'm using read.zoo as a function. If you really want to see what this function means, you can type ?read.zoo. If I am doing a read.zoo, okay. So read.zoo and write.zoo are convenience functions for reading and writing zoo series from R to the text file. So here my text file is CSV file. I'm reading a zoo series. Zoo series is nothing but a time series kind of a data. Zoo series from the CSV file, if I have to read, I can very well use read.zoo. So they are typically much better than read table, read.table or write.table kind of function, especially if your data is having a time series, right? So let me go ahead. So here you see what are the important things. You require the file name. If the format is there, you have to specify the format, the time zone. If at all is there, you have to pass that. Any kind of a function for computing the index. So you have some set of arguments that are coming out there. So let's start writing the same. Okay, let me write it as, so whatever is the read.zoo, will assign it to a variable called sensex, right? So let me do a read.zoo. First thing I want to look at is the file name. So it is lying in my E drive. R data is the name of the folder, and within that I have the file name as sensex.csv. So I am reading that particular data altogether, and then here this is a CSV file. So the comma separation is there. So I have to identify what is the separator. So because this is a CSV file, obviously the separator is a comma. So one more important argument that I am passing is sep equal to comma. The first column of the data as header. The first row of the data as header. So I'll say header equal to true, and the format of the date. So I have to specify the format of the date. So if you had seen this data, the date is in day slash month slash full year. Full year is shown with a capital Y in R. You have to refer to the time series notations. So this kind of a date is represented as percentage D. Right, let me go here and say percentage D slash percentage M slash percentage capital Y. This is the format, and keep that format in double quotes. So this is the This is the date that you have in Excel that you want to read it in a time series format into R. So let me read this read.zoo. Yes, there is no error in this line of code. And quickly to check whether we got the data right or not, I can do head of Sensex where I'll get the first few entries. Yes, it is reading it always as YYYY dash mm/dd, but if we have it in a different format, we have to specify the format in which we have our data. So it has read right from the first day, first 6 values, and if I want to see the last 6 values, I can very well talk about tail of Sensex. I have got the data until 2015 12/31. So for all these, I have definitely got the value. So I got the head of the Sensex, I got the tail of the Sensex. So first thing, what I suggest is, let's go ahead and do a simple plot of the data to get a clear picture. We'll do a kind of plot of the Sensex values. Right, we'll do a simple plot of the Sensex values to get first impression of the data. So let me do the plot of the Sensex data. So Sensex is the variable, so I am doing the plot of the Sensex. Right, if you want to put some heading to that graph, I'll say main. Main is what is the name of the heading. So Sensex daily closing prices values. So that's the name of the heading I am putting. And if I really want to put the labels, so if I want X label, I'll say X lab, where I can take date is on the X axis, right? And probably if I really want the label of the Y axis, I'll say Y lab, and I'll say Sensex values. Right. So we'll do a simple plotting to understand the data. So this is one more thing that we can do once we get some kind of a time series data. Wow. This is how the Sensex has been moving from 2000 till 2015. So you could see how easy it is to plot this kind of a chart. Right. Then comes, so now that we know this is our data, if I really want to know what is the highest value, all-time high of Sensex, I can simply say max of Sensex. Right? I'm just reiterating some of the functions that you know. Once you look at the time series data, what all you would like to look at. The max of Sensex has gone till date to 29,681.77. But when did it occur? That is where I can accomplish through which max of Sensex. Which record contains the maximum value? Right? Which dot max? Sorry. So which record contains the maximum? So I can say which dot max of Sensex. It says to 3760th record contains the maximum value of the Sensex. So if I really want that full record, I can very well say Sensex of, I'll do a subsetting from the whole Sensex. Sensex of which dot max of Sensex. If I do a subsetting of that using square bracket, I get this notation. Yes, on 29th January 2015, Sensex has recorded a maximum value of 29,681. So we can very well extract this kind of information also once we have a time series data. Now, I'll introduce you to the next important concept which we would always deal with a time series data is the computation of the returns. Generally in time series data we are more and more bothered about the returns rather than the prices, because we generally make an assumption that the returns are more stationary in nature. What is the meaning of stationarity? We find that for any specific time period, the expected values are going, the mean, the average value is going to remain to be the same, and almost all the properties, even the variance per specific, per any set of time series is going to be the same, and the kind of covariance between two different time periods is only going to depend on the lag. So that is what we call as a stationary time series. So generally we assume that the returns are more and more stationary compared to the prices. That is where when it comes to the time series calculations, we are more interested in understanding the return. But even with respect to returns, we have simple returns and we also have continuously compounded kind of a return. Right? Now, these two things can very well be handled in R. So let me do one thing. Let's see how we compute both of them. So I'll say return, simple return. We'll use simple return. First, we'll compute simple return. What is the way we compute simple return? The price of day 2 minus price of day 1 divided by the price of day 1. So which means this is the difference in the prices divided by the previous day's price, and if you really want to convert it into a percentage, multiply it with 100. Now the same thing, the numerator is difference. So in the time series data, a simple diff will give me the difference between the two consecutive days. So the diff of Sensex is nothing but I am getting the difference P2 minus P1 divided by P1, one previous day's value. This is what we call as lag. Lag of Sensex. One day previous value. That is lag. So lag by how many days? That is what is specified as K equal to minus 1. So when I say lag of Sensex, comma K equal to minus 1, it means one period lagged value of the Sensex. So I am simply saying take the difference of the Sensex values P2 minus P1 divided by the lagged value which is P1 and multiply that with 100. So you will get the simple return. So if we really want, we can check out head of ret underscore simple. So how much am I? So for each of the days, first day I will not get because I don't have the previous day for that first day. So it is starting right from 4th Jan, whereas the data is from 3rd Jan 2000. Returns are starting from 4th Jan 2000. So it is basically like 5491 minus 5375 divided by 5375, which is working out to 2.15%. If I had to find out the continuous return, I'll say ret underscore continuous and the same. But here, what is that we take? We take log P1 or log P2 by P1, which is nothing but log P2 minus log P1. So which is nothing but difference of log, this is the difference of the log sensex value. So this is what I am trying to give here. So difference, I am trying to find the difference from one day to the next period. I'll take the log of sensex. And if required, I multiply it with 100 to maintain the consistency. So this is how I get the continuous return in R. So even quickly I can check the head of return underscore continuous to see how the values are coming. So this is like simple is like an arithmetic return, continuous is like a geometric return, and we should always understand that the geometric return is slightly lesser than the arithmetic return. So this is what I could see. If the arithmetic return was 2.15, geometric is 2.13. Minus 2.44, minus 2.47. So slightly lesser than the arithmetic always. So we got both. So whenever we look at the time series, we can look at the returns. From the data, we can simply compute the return. Then the other important aspect that is worth looking at when we open any kind of a time series data is finding out the summary statistic, finding out the summary of that particular data, whether it is for simple returns or for continuous returns. So here I generally use this particular function, core data. Core data is a function, especially it uses only the prices, it doesn't use the dates, because the dates may not be sequential. So when I am using it as core data, the date is simply ignored, only the stock prices are typically considered. So I'll show you the difference. So I can very well say summary of return underscore simple. So for this simple return, I'm trying to find out the summary value. Yes, these are some of the things that I'm getting, right? If I'm looking at simply saying summary of return simple, I'll get some kind of a summary for the index, and I'll also get some kind of summary for the return simple. But the same thing, if I modify it as summary and I consider core data of return simple, the dates are typically not considered for the summary purpose. Only the core data, only the return simple column will be considered. The index will not be considered. So that is what is the advantage of taking core data. So I get a minimum value is minus 11.14%. So there was on one single day, the Sensex has fallen over the last 16 years. There was one single, there was a day when the Sensex has fallen by 11.14% in a day. And there was a day when the Sensex has gone up by 17.34% in a single day. So I really want to find out which day this kind of a fall has occurred. If you remember, we have already handled that kind of a situation. So I am simply using ret underscore simple. I am doing the subsetting of that. Right, I'm extracting one subset which is equivalent to the minimum value. So I'll say which dot min ret underscore simple. So the simple return, whichever is the minimum value, I'm simply extracting that from the return simple data. So it says that on 17th May 2004, there is a minimum value of minus 11.13% return that Sensex has generated. Sensex has lost 11.13% on one single day. So if at all this has been a very absurd kind of a result, very much irritating kind of a result, probably you can very well, or when it is more and more an outlier kind of a result, you can very well do a quick search on the internet to really find out what has happened on that day which made Sensex fall by such a bigger number. Similarly, if I want to know the maximum, okay, let's see when the maximum return has occurred. I can very well change it to which dot max. It says that on 18th May 2009, there was a 17.33% growth in the value of Sensex. So we can really understand what were the drivers for this growth, what was the drivers for that kind of a fall. Or even more better, instead of just relying on one single value, I can even think of a relative frequency distribution of the data. Right? I could very well see how the data is distributed over the period, how the daily returns are distributed. This is where I talk about we can use a histogram for the plotting of this kind of a data. And histogram, okay, we'll do a very basic histogram first. I'll say I'll say simply hist ret underscore simple. The same thing you can do with continuously compounded returns as well. I'm just giving you different kinds of functions which you can really rely upon. Whenever you look at the basic time series data, this is how you have to really get started off with. Okay, I'm looking the histogram. So there is some kind of breaking up of the data which R has done on its own, and this is how the histogram has come. Sometimes we find that the gap is too wide or too narrow. So if we really want more number of boxes, I can specify the breaks. So what I'll do, the same histogram, right? I'll specify how many breaks I want, how many groups I want. Let's say I want 100 breaks. And probably to make the graph look better, I can put headings, main, right? I can say histogram of simple returns, right? I can very well specify that. That's the name of the chart. And if I really want the labels in the X label, I would like to take it as the percentage of returns. Okay, so now you could see the graph is looking much more better because it has broken the whole data into 100 parts. Instead of the system determining how many, instead of R determining how many, we are looking at the data, and from there we are breaking the returns into our own list, so which is giving a much more a better picture. Or we can even look at the density plot also, right? So we can very well see different kinds. So I can very well say plot of the density of the return symbol. So I am making a plot where I am computing the density. So it shows me the kind of a pattern that is present in the return data, looking more or less kind of a normally distributed kind of a return pattern, right? So either I can plot a histogram or I can get some kind of a density plot of the daily return. And let's say if I really want, now this is a huge data over 16 years, right? Let's say only in the last year, in 2015, I want to restrict my analysis only to a very small subset of the data. Let's say only for 2015. So I can very well create one variable called Sensex 2015, and from there I'll use the window command. Window is a kind of a subsetting I can create where I'm taking a subset from the Sensex, right, and from the overall Sensex data. So date wise I can do a subsetting. That is what a window command is helping me out with. So I'm giving a start date. Let's say I want it from 2015. I have to give it in the standardized date format. So I'll give it as within the quotes, within single quotes, 2015 0101. So this is the starting point, and I'll specify the ending date also. The ending date also comes out with 2015 1231. So I want my data to be picked only for this particular period, only from 1st Jan 2015 to 31st December 2015. So that is what I am calling it as Sensex 2015. Probably just to check out, you say head Sensex 2015. Yes, the first value is starting from 1st January 2015 and it is going ahead. Right? So within this also, if you really want to find out what is the maximum or what is the minimum, what is the minimum return or what is the minimum value that the Sensex had during this period, right? So I can very well specify Sensex 2015. Out of this, I want to find out which dot min Sensex 2015. So which value is the minimum? So it says that on 7th September 2015, Sensex has registered a minimum value of 24,893. So you can very well extract those kind of things also when you are using the time series based function. And then one more thing I want to specify here is the quantile. First quantile, first percentile, second percentile, 99 percentile. We are very well interested in using the word quantile from a risk management perspective. If you remember, the computation of value at risk is primarily based on this quantiles itself. If you remember, if you define what is value at risk, we are talking about the probability with a 1% chance. If I am saying 99% value at risk, right, we are simply saying that 99% value at risk is some X percent, let's say 5%. The probability that the return is below 5% on any given day is only 1%. That is how we are defining the value at risk, right? So if I really want to know that particular thing from the historical data itself, I can very well compute the quantile. So that's where I'll use the quantile function for the return simple or return continuous, whatever is. So return simple, and I'll simply specify if for whatever is the percentage. So if I really want 99% or 1% extreme value, I'll take probability as 1%, 0.01. So by specifying the probability here, I can get that appropriate quantile value. So it says that minus 4.32. So there is only a 1% chance that on any given day, Sensex falls by more than 4.32%. Right? There is only 1% chance that on any given day, the value of the Sensex falls by more than 4.32%. So like this, once you have a time series data, you can very well do these basic workouts before you get ready for any kind of modeling and forecasting exercises. So this is what you have to practice. Of course, there are few more functions that you can look at, but a preliminary view of initially once you have the data, what is that you can do, how do you load that time series data into R, and what are the basic kind of computations that you can perform on it. Thanks a lot for listening to this session. Thank you very much.